What's up, guys? Welcome back to another LeetCode video walkthrough. Today we're going to be going over LeetCode number 236, lowest common ancestor of a binary tree. So given a binary tree, return the lowest common ancestor of the two nodes in the tree. And according to the definition of an LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Some examples are as follows. So if we were given this tree and the value of P is 5 and Q is 1, we have to return 3 because the LCA of nodes 5 and 1 is 3. And then in this example, we can see a case where one node is the common ancestor of another. So in this case, if P is 5 and Q is 4, we simply return 5 because by definition, a node can be a descendant of itself. So first we have to recognize that there are three scenarios. Either P is a descendant of Q, Q is a descendant of P, or both P and Q are descendants of another node. And from this, we can use the following algorithm. So if a node we're visiting is none, we simply return none. However, if a node we're visiting is either equal to P or Q, we simply return the node's value, because by definition, the lowest common ancestor can be itself. Like a node can be its own common ancestor. Else, we recurse the same process on both the left and right subtrees. And after we get a value from each, we evaluate it as follows, right? So if a non-null value is returned from both subtrees, it means that our current node is an LCA and we return it. And the reason this is the case is because if a non-null value is returned from both subtrees, it means that we found either P or Q in the left subtree and either P or Q in the right subtree. And by construction of the binary tree, we know that the least common ancestor is our current root value, right? If we go to the left or to the right, we're going to avoid the subtree that either one of P or Q is in. However, if at least one of the values returned as null, what we do is we simply return the non-null value. And what this means is that both P and Q were in one of the subtrees, and both P and Q were not in the other subtree. So going over an example, so I have the same tree constructed here, and let's say that let's start with the P equals 5 and Q equals 1. So initially, we start at the node with value 3, and 3 is not equal to P or Q, so what we do is we recurse onto 5 and onto 1. And so for 5, we see that, okay. So we can start with the left subtree. So we first recurse to 5, and we see that 5 is equal to P. So what we do is return 5. So L equals 5, which is the return value from the left recursive call. And now we can make the right recursive call of 1. And we see that Q equals 1. So what we do is return 1. And now we evaluate the values that we got back. So because both values were non-null, this means that our current node of 3 is the common ancestor, and we return 3. Now if P is 5 and Q is 4, we will start the same process. So start at 3, go to 5, and we see that, oh, my bad, Q is 4. Yeah, so we see that 5 is equal to P, and we return 5, and now we do the same process for the right. So we look at 1 is not equal to either, so we do recurse on the left, go to 0, 0 is not equal to neither, So we do L equals N for none, and then we go to the right subtree. 8 is not equal to neither, so R equals N. And because both values were non-null, what we would do is return null, so R equals N. And because left is non-null and right is null, we return the left value, so the return value for this would be 5, and that makes sense because 4 is in the subtree that 5 is in, and 5 can be a descendant of itself by definition, so that checks out. And now let's go to the final case where P equals 2, Q equals 7. So again, start at 3, go to 5, go to 6, and then, so we return null from 6, so do L equals N. And now we go to 2, and 2 is equal to P, so we return 2. And we see that left is null and right is 2, so we return the value of 2. And this makes sense because 2 is 7's ancestor and its own ancestor. So that was a pretty straightforward LCA problem, and thanks for watching.